Hi everyone. In this video we'll be looking at section 7.4, picking up where we left off. In the last video we found out the formula for the the arc length of a smooth curve starting from A and going to B, and now we'll look at some examples of that. So here's our example. Find the arc length of the graph of y equals x cubed over 6 plus 2 over x on the interval from 1/2 to 2. So we could graph this. And if we graph this would be our graph, right? And we are interested in the graph from 1/2 to 2. So if I were to draw this, right, and then this would look something, like this. So this is our graph of y, and we want to go from 1/2 to 2. Right, and that looks pretty good. So what we're trying to find here is this length from here to there, right? So what do we need to find for our formula? Remember, in general, our formula equals the integral from A to B of 1 plus the derivative squared dx. Right? So A and B, we already know where we start and finish. We're given that by the problem, but now we need to know the derivative, right? So we need to find the derivative. In this case, our function is y, so our derivative is dy over dx, and that's going to be equal to, if I took the derivative of x cubed over 6, I would get 1/2 x squared, right? And then if I took the derivative here, 2 over x is the same as 1 over 2x is the same as 1/2 x to the negative 1. So when I take the derivative, I get minus 1/2 x to the negative 2. I could factor out a 1/2 from each of these terms, and I'd be left with x squared. And remember, x to the negative 2 is the same as 1 over x squared, right? So that's my derivative. 1/2 times the quantity x squared minus 1 over x squared. So my answer for the arc length is going to be the integral from 1/2 to 2 of 1 plus 1/2 x squared minus 1 over x squared, all that squared dx. All right. So let's go ahead and square it. If we do that, we get 1 plus, and now we get 1/4, because I would square the 1/2. And now if I square the quantity, x squared minus 1 over x squared, remember we have that trick, the first one squared, so x to the 4th, 2 times the first times the second, so that would be minus 2, because when I multiply x squared times 1 over x squared, I get 1, and then plus 1 over x to the 4th, right? Because that is 1 over x squared, quantity squared. Now what I can do here, again, this is kind of a little bit of an algebra trick, and you'll have to do this on these arc length problems, some algebra tricks, is I can actually pull out a 1/4 of both terms, right? So my first term is right here. That's my second term. My first term is the 1, right? So if I pull out a 1/4 out of both of those terms, if I pull out a 1/4 from 1, what's left over? Well, what do I multiply times 1/4 to get 1? I multiply 4, right? So the green comes from factoring out a 1/4 from 1, and then plus, if I factored out a 1/4, then I'd be left with just the part in orange, right? X to the 4th minus 2 plus 1 over x to the 4th. All right, so what did I do in this step? I factored out 1/4. Okay, why do I do that? Because I can take the square root of 1/4, right? The square root of 1/4 is 1/2, right? So that can come out front because that's a constant. And I have the integral from 1/2 to, and then now notice that I can combine 4 and 2 here. Oops, should have underlined this part because this part came from the orange there. But notice now that I can combine the 4 and the 2. And if I do that, I will get x to the 4th plus 2 plus 1 over x to the 4th, all underneath the square root. All right. Okay. Now here's what another algebra trick. We need to know for this problem that, or we need to realize that x to the 4th plus 2 plus 1 over x to the 4th, well, that is a square of some binomial. If I squared x squared minus 1 over x to the 4th, plus, and it's not to the 4th, it's x squared. If I squared this binomial, then I would get the first one squared, which is x to the 4th, plus 2 times the first times the second. Well, the first one is x squared times 1 over x squared. That gives me 1, so that would give me 2 there. And then the second one, 1 over x squared is 1 over x to the 4th. So you're going to have to get used to these binomial squared and what they look like, right? But because this is true, this purple can be replaced with x squared plus 1 over x squared quantity squared. Why is that helpful? Well, because the squareds in the square root cancel out with one another, right? Here I get 1/2, 2, and then I would get x squared plus 1 over x squared quantity squared all underneath the square root dx. And again, the squareds in the square root cancel out, and I'm left with 1/2 the integral from 1/2 to 2 of x squared plus 1 over x squared dx. Now that is an integral that we know how to solve. Right up here at the beginning, this integral we couldn't solve, so we had to play some algebraic games. Right? So at this point, this becomes 1/2, 1/3 x cubed minus 1 over x, evaluated from 1/2 to 2. And if you do that, you get the answer 33 over 16. Right? So in this problem, the tricky part is playing the algebra game. Okay, so in this next problem here, I want to find the arc length of the graph y minus 1 quantity cubed equals to x squared on the interval. This interval here, I should have specified, this is the x interval. So the first thing we should notice here is my function y minus 1 cubed equals x squared is not in terms of either x or y. In other words, it's not x equals y something something or y equals x something something something, right? But since our interval is in terms of x values, we should try to solve this for y, so it's y equals x something something something. So we'll try that first. So let's try to solve y minus 1 cubed equals x squared for y. So if we do that, I would get, if I'm solving for y here, I need to take the cube root of both sides. So I get y minus 1 is equal to the cube root of x squared. So y is equal to, I'm going to rewrite the cube root as x to the 3/2, right? So this is x to the 3/2 plus 1, right? And remember, what do we need for arc length? Our arc length formula is 1 plus the derivative squared underneath the square root, right? So now we need to find dy dx. We need to find the derivative, right? So dy dx, I take the derivative here, I get 3/2 x to the 1/2, right? Which doesn't seem right. Let me check what I'm doing here. Whoops. This should have been 2/3, shouldn't it have been? I apologize. 2/3. Why 2/3? Well, cube root is what we're doing, right? The root goes on the bottom. So this should have been 2/3. So this is going to be 2/3 x to the negative 1/2, which is 2 over top of 3, the square root of x, right? But here is where we have an issue. Notice that if I were going to plug this into our formula is s equals the integral from a to b of 1 plus the derivative squared square root. But now remember b or a in this case is 0. If I try to plug in 0 into my derivative, what happens? dy over dx is undefined, right? I get a 0 in the denominator, which is an issue. So what that means is we can't do this in terms of y. We're going to need to do this in terms of x. So now we know we need to try to solve y minus 1 cubed equals to x squared for x. So we got to go with the other variable this time. Okay, so if I were going to solve this for x, I would get x is equal to plus or minus the square root of y minus 1 cubed, right? So in other words, plus or minus y minus 1 to the 3/2. In this case, I did it right because the root is on the bottom. So what do? We're going to choose the positive 1, y minus 1 to the 3/2, right? We get that plus or minus, but we really only need the positive. And I'll show you why. Let's look at the graph. Y minus 1 cubed, right? So this is our function here. Y minus 1 cubed equals to x squared, right? That's our graph. And what do we want? We want the integral from the x value 0 to 8. Notice from the x value 0 to 8, I have positive y values, right? In this case, actually, I have positive y values in both cases. But in this case, I have positive y values, so I am allowed to choose the positive one, right? So this is my function. So now we need to find its derivative. Notice this is a function x equals y something something something. So its derivative is called dx because the function's called x over dy because we're taking the derivative with respect to y. In order to take the derivative of y minus 1 to the 3/2 when our variable is y, we need the chain rule, right? So if I were going to do this with the chain rule, take the derivative of the outside function, which I get 3/2, leave the inside alone, y minus 1, and then that's to the 1/2, and then I would multiply times the derivative of the inside, but the derivative of the inside, y minus 1, is just 1. So in other words, I get 3/2 times the square root of y minus 1. Okay, so now remember, what am I trying to do? I'm trying to find my arc length, and remember my arc length formula is s equals the integral, and this time since it's from it's in terms of y, I need to go from c to d of 1 plus my derivative squared dy. So what am I missing here? I need my start and finish. This x equals to 0 and x equals to 8 that we have won't work, right? Because everything's in terms of y. So we need to find c and d, i.e. our y interval to integrate on. How are we going to do that? Well, we know our x integral, or our x interval, sorry. So we'll just change those x values into y values. So at x equals to 0, because we're going from 0 to 8, what is y? Well, our function is y minus 1 cubed equals x squared. So if x equals 0, this means 0 squared y minus 1 cubed, right? 0 squared is just 0. If I take the cube root of both sides, I'd be left with y minus 1 equals 0 because the cube root of 0 is 0. So I get y equals to 1, right? So that's my starting y value at x equals to 8, right? Because that's my ending y value given by the problem. I get y minus 1 cubed equals 2x squared, but again, x in this case is 8. So I get y minus 1 cubed equals to 64. The cube root of 64 is 4. So I get y equals to 5. Right? So this is my starting y value, and this is my ending y value. Now we're ready to go. Right? So now we find the arc length. So S is equal to the integral from C to D of 1 plus the derivative squared. Whoops, I should write that with respect to y. Whoops, what am I doing there? Square root dy. So I get the integral from 1 to 5 of 1 plus, what's our derivative? Our derivative is 3/2 square root of y minus 1, all of that, because that's my whole derivative, squared dy. Oops. Okay, so now we simplify. The integral from 1 to 5 of 1 plus, so 3/2 squared is 9/4, and then y minus 1 squared is, the square root of y minus 1 squared is just y minus 1. Okay, so now I get the integral from 1 to 5. 1 plus 9/4 y minus 9/4 if I distribute that 9/4. Now I need to combine my 1 and 9/4. I'm left with 1/5. And then I get 9/4 y. 1 minus 9/4 is 5/4 minus. Right? What do I see common in both of those terms? A 1/4. So let's factor that out. If I factor that out, I'm left with 9y minus 5, all underneath the square root. That's convenient because the square root of 1/4 is 1/2, right? So I can pull that 1/2 as a constant out front. 1 to 5 of the square root of 9y minus 5 dy. Now, to integrate this function, I need u substitution. Right? So what I'm going to do is do that as my side work here. I'm going to evaluate this integral through u substitution to find its antiderivative. Right? Because I can't just take the derivative, or I can't take the antiderivative because I've got an inside function. Right? So my integral here is the square root of 9y minus 5 dy. My inner function is u, so that's 9y minus 5 du over dy. Taking the derivative of that is 9, which means that my dy is equal to du over 9. So in other words, my integral becomes the integral of u du over 9. Now again, I'm breezing through this really fast because u substitution is something that you should have learned in Calc 1. Right, so this becomes 1/9 the integral of u to the 1/2 du. 1/9, when I take the antiderivative, I get 1/2 plus 1 is 3/2, so 2/3 u to the 3/2 plus c. Right, so then I get 2 over 27 u to the 3/2 plus c. Final step, substitute back in. 2 over 27. What is u? 9y minus 5 to the 3/2 plus c. So that is the antiderivative. So that's what ends up getting plugged in to my function here. Right? So now I do 1/2. Now what's my antiderivative? My antiderivative is 2 over 27, 9y minus 5 to the 3/2. And now instead of plus c in this form, or in this integral, I have a definite integral, so I'm going to plug in 1 and 5. All right? So now if I do that, I get 1/2. 9 times 5 is, well, actually, I can pull out the 27, right? So the 2's cancel out, and I'm left with 1 over 27. And then now, if I plugged in 5, I would get 45. Minus 5 would be 40 to the 3/2. Minus, if I plugged in 1, I get 9 times 1 minus 5, which would be 4 to the 3/2. So that's my final answer, and that is approximately 9.073. Right? So that was a tricky one just because I had to try x. It didn't work. So then I had to integrate with respect to y. And then even more troublesome, when I integrated with respect to y, I had to use substitution. All right. So one more problem here. Let's find the arc length of the graph of y equals ln of cosine of x from 0 to pi over 4. So I could draw the picture, but it's not entirely important for this. Remember, what do we need here? For our arc length formula, we need to find the derivative, right? And our function is already y equals something something x, and our start and finish is in terms of x, so life is good. All right, so let's find dy over dx. Let's find the derivative. In order to find the derivative of this, it's ln of cosine of x. So again, it's a function inside of a function where I need the chain rule. So I do the the derivative of ln of something is 1 over that something. So I run over, leave the inside of the function alone. Now I chain on the derivative of cosine, which is negative sine x. All right, so this is negative sine x over cosine x, which is negative tangent of x. Okay, and now we move on to our formula. Our arc length is equal to the integral from 0 to pi over 4, because that's what the problem tells us. 1 plus our derivative, which is negative tangent x squared, all underneath the square root, dx. So we should simplify this. 1 plus negative tangent squared is positive tangent squared x dx. Remember, this is a trig identity. 1 plus tangent squared x is equal to secant squared x. We need to get comfortable with our trig identities, right? And so since 1 plus tangent squared x is equal to secant squared x, I can replace that in our problem. So 0 pi over 4, I can rewrite this as secant squared x underneath the square root. But then the squareds and the square root cancel out. I'm left with the integral from 0 to pi over 4 of secant of x. Another thing we need to know is what is the integral of secant, right? This one's actually kind of tricky, but it's one we need to know. So the integral of secant x dx is equal to ln of the absolute value of secant x plus tangent x plus c. All right, so these are the two things we need to know for this problem. So plugging that into our problem here, we get ln of secant x plus tangent x evaluated from 0 to pi over 4. Actually, I take that back. We need to know one more thing, that secant x is equal to 1 over cosine. This will help us because most of the time we're familiar with cosine and sine of our important angles like pi over 4 and 0, whereas we're not as familiar with what secant is off the top of our head. Right? So let's plug pi over 4 in. So secant of pi over 4 plus tangent at pi over 4 minus ln of secant at 0 plus tangent at 0. Right? So what is secant at pi over 4? Well, cosine at pi over 4 is radical 2 over 2, right? So what does that mean? That means secant is 2 over radical 2, all right? Plus, what is tangent at pi over 4? Well, tangent at pi over 4 is y over x, so it's radical 2 over radical 2 over 2, which is 1, minus ln. Well, what is secant at 0? Well, cosine at 0 is 1, so secant at 0 is 1 over 1, or 1, minus what is tangent at 0? Well, the y value at the angle 0 is 0, so it'd be 0 over the x value, and the x value is 1, so this would be 0, right? Most people don't like radical or 2 over radical 2. 2 over radical 2 is equivalent to radical 2 if I multiply both the top and bottom by radical 2. So this becomes ln of the absolute value, but we can get rid of the absolute value because radical 2 plus 1 is positive. So radical 2 plus 1 minus, well, what is this? This is 0. Ln of 0 is 0. So this is our final answer here. It would be minus 0. All right? And that is approximately 0.881. All right, so those are some examples of arc length. Again, the formula is not too difficult, but some of the integrals get a little bit tricky and they require some algebra or some u substitution or something like that. Thank you.